a dataset that we generated for automatic hint generation that we tried to generate hints for Factoid questions. At the first, I want to talk about some backgrounds about our topic. As you know, today's people use a lot of large language models a lot in their lives, such as ChatGPT or Bing, and also it could be dangerous for students, especially that because they can use the system to find their answer. It could be dangerous for cognitive skills such as thinking or reasoning. Because of that, we decided to use hint generation systems. These systems generate hints instead of direct answer for Factoid question, and it could be useful for students and also for people that needs to improve their cognitive skills. You can see our task schema here. Instead of generating directly the answer, we generate the hints by our system and show the hints to user and let him to think about the answer and find the answer by themselves. Our main objectives will be generating a large-scale dataset, the first dataset for automatic hint generation at first, and then for the first time we decided to generate some automatic evolution method for assessing convergence and familiarity quality attribute that we talk about them in the next slides. At the first, I want to talk about the framework that we use here. We decided to use TriviaHG dataset because it's a so challenging dataset question answering. Then we remove some question with wrong answer from them and select some question with high quality from that dataset and ask being Copilot. Now we know it as Copilot now. To generate hints, and then we remove some answer leakage and bad quality hints from the dataset. Finally, we could have a big dataset with 16,000 questions and 160,000 hints. Here you can see our dataset distribution for train, validation, and test. Also, you can see here we try to have a fair distribution between some data sets, and for validation and test they are exactly equal based on the question types. About the convergence evolution, it's an evolution metric that shows us that how much a hint can narrow down a candidate answer in our mind. For example, it would remove a lot of candidate answers in our mind to reach to the answer. We call this evolution method as convergence, and it's the framework that we use. We decided to use large language models. At first, we generated some candidate answer by large language models, and then we asked large language models about which candidate answer is true for corresponding hint, and finally we computed a score for that. About the familiarity evolution metric, I can say it shows how much the entities in the sentence is familiar for the users. To compute this evolution metric, we decided to use Wikipedia based on the number of distinct Wikipedia pages. We generated a metric for hints. Here you can see the results of the results that we asked human about the quality of hint, and we asked them to answer the question based on the hints that we generated. The blue column showed the hint that we generated, and the other column showed the hint generated by other large language models such as Llama. And here you can see the results of convergence and familiarity automatic evolution metrics that we use for different methods to generate hints for us. And it shows the hints that we generated is the best. As a conclusion, I can say we showed that hints can help humans find the answer because we asked them to show that. And then we also showed that the users can use our dataset to find their models. And also we showed we can evaluate hints by automatic hint generation methods. And for future, we decided to use hints as a context for rank in question answering system. Thank you.
So thank you very much for your presentation.